CloudDB, shaping your new normal.
Hello, everyone. Today, I'd like to talk about, and Abhijit, my colleague, are going to talk about graph and machine learning for cybersecurity. It's about the combination of graph analytics capability of Oracle database and machine learning capability, which is cool. In the first part, I would like to talk about the scenario according to this blog post, which I have posted a few months ago. And at that time, I have done this with Graph OPG for Pi, Python client for Oracle Graph Server, which is running on Graph Server, and I used it from Jupyter Notebook, which is independent from Oracle database, and as well as the built-in functionality, machine learning functionality of autonomous database, or ML for Pi. But today, Abhijit has succeeded to combine these two tools on one single autonomous database. So he will show the environment later. Before that, I would like to briefly talk about the story. So this is basically a scenario for intrusion detection from packet captures. When you think of the data of packet captures, it must have the source IP address and destination IP address, and maybe protocol. But besides those information, it's more difficult for us to get more details about those packets because the networks are always encrypted, right? But from the transactions of all those packets, maybe we can figure out the anomalous activities of one particular IP address. So when you have a network like this, you might get the information of the victim IP address, and that address, well, let's say if it is a malware victim, malware is coming to this victim machine from somewhere, and after that, that malware is sending, well, the messages to particular places or the IP addresses, connected IP addresses, and that activity, sending packets and receiving packets, that might be some somehow abnormal, right? So we would like to capture such feature of the graphlet, which means a small graph, or which is involved in the receiving and sending packets activity of one victim address. So when we have such packet capture information, maybe we can create a small graphlets, a lot of graphlets, and maybe we can have a model, machine learning model, to classify whether those packets are benign or malicious. So for that, to do this, we need to create graphs from such packet capture information, and then we can calculate the features for each graphlet, like each graph. So basically, it's kind of the topology of this graph itself, whether those IP addresses are well connected or sparse, and what sort of pattern they are. Then we can use such graph features for classification using machine learning. So for creating graph, we can use OPG, Oracle Property Graph. Oracle Property Graph has a feature for converting table data into graph. Also, Property Graph can create features using built-in algorithms such as calculating the degree centralities, page rank, etc. And then after that, we can write the feature down to a new table, and we can use that table for classifying whether they are anomal or not. If you have flags for training, which means the known malware graphlets, we can use that information for learning and training the model. Okay, to do that, we can connect from OPG4Pi to database or a graph server, which is running on database. And then from these benign table, benign node table and edge table, and we also have a malware vertex table and edge table. Using those source tables, we can create graph using create property graph statement. This is a declarative way to convert table data into graph. So basically, the benign vertex table. From vertex table, we can create nodes, vertices, and edge table has the transaction between those nodes, right? Then we can execute this DDL to create many graphlets, and then we can run algorithms to get the features of the graphs. To do this, we can use analyst object to run those functions like a degree centrality, local clustering coefficient, page rank between a centrality, so that we can extract the features and of those graphlets. After that, we can have this table, which has many features which are generated by those algorithms. So without this information, we only know about those graphlets whether they have, let's say, 5 nodes, and maybe that's it, and their IP addresses or something. But it's not so informative for making classification model, right? But now we have a lot of features about those graphlets, so we can use this for machine learning. To do this, we can run this store function to create a new table on the database and write this table into the new table on database. We can do that for benign graphlets and malware graphlets, and then combine these tables into one, having those having a flag ML level, which means these are anomalous graphlets. That's why it has they have a flag 1, while benign graphlets have flag 0, right? So we can run, maybe we can visualize the graph as well, but the main topic is to create a classification model. So we can use the new feature tables as an input for OML and run training functionality to get the, well, this is a parameter for OML neural network. So we tried neural network first to create a model, and it has a performance of the accuracy 98%. But at the same time, we can use AutoML, which is a functionality of our autonomous database, to pick the best performance models, algorithms for creating machine learning models. And with this, other algorithms such as naive Bayes, support vector machine, and general linearized model, and they actually have better performance than neural network. Okay, so this is the brief explanation of the story. So can I switch to Abhijit to explain about the environment, how we can have an environment on autonomous database?
Sure. Thanks, Dr. Yeah. So I'll just walk you through the environment. So Rata explained about overall story, how all this works, but how this is implemented, we'll see that shortly. So first, I hope you can see my screen. Right?
Well, still waiting.
Okay. Rata, just let me know once it is loaded.
Yes, screen loading.
Okay.
It is taking time.
I see. Okay. Sorry. Okay. Now you can see my screen?
Yes.
Okay. All right. So first of all, what we are doing here is we are trying to upload data, graph data into autonomous database. So using autonomous database, Graph Studio, even tables can be directly modeled into graph data. Here we have the edges and nodes vertexes tables. So you can see benign edges and benign vertex tables here. Likewise, the tables for malware edges and malware vertex also are there. So basically here, if we look at one of these tables, you'll see what Rata explained, the IP addresses of source, destination, source type and destination type for these edges, right? So likewise, for malware, vertexes also similar information for nodes. So these tables are populated in autonomous database, and on that we can then do graph analytics, create features using graph analytics, and then train a machine learning model, right? So this is just to give you a glimpse that this is how the data looks. Now, once these tables are loaded into autonomous database, we can use Graph Studio, which comes along with autonomous database. And with Graph Studio, you can model tables into graph data. You can work. There are notebooks available, so you can use Zeppelin notebook. So here we have notebook to do graph analytics, where we are applying graph algorithms. So first we read the data that we have loaded in autonomous database. So first the graph session is established. Then we read data from the tables. So vertices and edges tables for benign and malware, packets, and then we create graphlets from that subgraphs. So graphlets are nothing but subgraphs which kind of show different patterns. So where certain pattern of activity of packets is can be grouped. So those graphlets are generated for both benign and malware packets, and then we generate these graphlet features for. So we pass each graphlet into this function and extract various graph features like centrality, clustering coefficient, and so on, betweenness, page rank, which kind of give a lot of additional information about how the graphlets are, how they each node compared to other node, what is the kind of separation between them, right? Things like that could be kind of measured using graph analytics algorithms. And once we have extracted those features, so these are the features you see for different each graphlet, and for graphlet, say, so this is for benign, and then for malware, similarly, we extract all the graph features. And then from those features, then we do some aggregations in terms of averaging, min max values, so that there are kind of variations in those features are captured. And we write that back into autonomous database, right? So all these features that we have extracted, we write into a database. So this is for malware, features malware, and features benign. So we have these tables. We have run this already, and we have the feature table. So a lot of these informative features have been extracted as we see in the code, right? So these are all features that we saw in the function, so all these features are stored into tables for benign and malware packets, graphlets. And once we have done that, then we train a machine learning model. So Oracle machine learning, we know that that's part of autonomous database. And so it is all the machine learning algorithms are natively available within database. And we can train predictive models. So here we are trying to train a classifier that will predict whether a particular graphlet that is benign or malware, malicious, using the data that we have extracted. Yeah, sorry about that. So here we are reading the data from the table. So features, benign and malware, these are two tables that we store the data. So these are the combined features for our machine learning model. And then we split data into training and testing. And so there is this ML label, which is kind of indicator for benign and malware graphlet. So that is also added, and we train different algorithms. So starting with neural network, and so we train that and different classifiers. So, and we then evaluate accuracy on the test data for the classifier that we have trained. Right? So neural network, neural base, AutoML, which Rita talked about. And based on that, we kind of get kind of leaderboard of different algorithms, different classifiers. Yeah, so this is how we kind of build predictive model to accurately predict for very limited data that we had, only IP addresses and type of packet and payload, just based on that, and then historical information about benign and malware labels. We leverage all that and then extract a lot of features from graph algorithms and build very accurate model that will help us predict malicious packets. And then using graph visualization, we can visualize these graphlets. So this is for benign graphlets. So what is the pattern? So it's kind of, we see some activity that kind of very kind of unique pattern. Here we see the packets are traversing between different IPs, until there is successful victim is found. Right. So this is for benign. We see those kind of patterns, and likewise for malicious activities also, we see specific patterns and activities of different packets. So this is what I have. Rata, you want to add anything here?
Yeah, well, I suppose the machine learning prediction result itself is not explainable. So when we get the list of suspicious graphlets, maybe we can check the graphlets visually on the graph visualization tool. That might help. Yeah. Well, but this is very cool.
Just to add one more thing. So Graph Studio is one way to kind of work with graph data. You can use Oracle Property Graph, OPG for Pi in Zeppelin notebooks directly on Autonomous Database. But second way is to kind of do it using Jupyter Notebook. So the things that we saw earlier, same thing here. It's Jupyter Notebook is deployed on Graph Server. So Graph Server and client can be deployed in OCI using Marketplace image. And on the Graph Server, you can install Jupyter Notebook and OPG for Pi. And with that, you can connect to using JDBC connection. You can connect from Graph Server to Autonomous Database and access the data, right, that we loaded. The same thing is done here through Jupyter Notebook. We are extracting those graphlet features, right, and then again storing that back into database. But now with Graph Studio, you don't have to do this kind of hard work of installing Jupyter Notebook into a Graph Server. You can directly work with Graph Studio. That makes life much more convenient, right? So yeah, that's additional.
Well, I had a talk using Jupyter before, but it needed a additional setup for not only Python client but also the Graph Server outside of Oracle database. So in that sense, it is now working on Oracle Autonomous Database inside. So this is the first presentation I think in the world that combining machine learning and graph analytics into one database. So I think it's so cool. And when we have been observing that this method is generic. I saw one customer who is considering the introducing this scenario into analysis of telephone network, whether those people are like a fraudster using telephone and calling to old people to tell a lie, right? So so I think it works for money transaction as well, especially for e-wallet. So this is very strong and new method, I suppose.
Yeah. Other thing, I mean, if you want to talk about this cool features of Graph Studio, which helps you model graph data from normal table. So you have this graph data modeler. So you have a relational table in your database. You can model that into graph data, and then you can work using notebooks. And then extract a lot of insights using graph algorithms. Yeah.
Okay. Yeah. Cool.
All right. I'll stop sharing now.
Yeah. Well, is there any question from participants? Maybe Richard. We cannot hear you, but I hope you enjoyed. Okay. So maybe we might have more chances to talk about this topic of the combination of machine learning and graph analytics in the future. But it's great to have this session to introduce that. Well, in the first time maybe. Thank you, Abhijit.
Yeah, pleasure.
Yeah.
Thanks.
And thank you everyone for
CloudDB, shaping your new normal.